to talk about inverse functions. Today we're just going to take a graphical approach to the idea behind inverse functions. There's a definition. Two functions are inverses if and only if, when one function contains a point A and B, the other function, the inverse function, contains the point B, A. You reverse the x and the y. Reverse the ordered pair to create an inverse function. Our first example here is a function that contains three ordered pairs. That's it, just three ordered pairs. The x values are the domain of the function. And oftentimes, mathematicians will put those in numeric order. Any order still represents the same domain. The range of the function includes the y values. Same thing, typically we would put these in numeric order. So if that's the original function, the inverse, which has this notation, f inverse of x, the negative 1 exponent represents an inverse. That inverse is going to be the ordered pairs reversed. 1, 3, 4, -2, and -1, 5. And since we reversed the x's and y's, the domain of the inverse has now become 1, 4, -1. And the range of the inverse has become 3, -2, 5. In other words, in general, the domain of the function, the original function, becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. Inverses are all about switching x and y. X and y interchanging, which means the domain and range also interchange. Here is a function that is represented in a table format. Well, it's at least a set of ordered pairs. We have to decide if it's a function. We have 4 ordered pairs, and because each x value, each input has only one output, or y value, it is a function. And if we wanted to write the inverse, we would just switch the values of x and y. An inverse is not always going to be a function, so we're going to check on that. We need to verify that each input has exactly one output, which it does. So in this case, the inverse is also a function. Let's graph those 4 ordered pairs. I'm going to graph them in blue. I'm going to reverse the ordered pairs mentally and graph those in green. Same. And I'm going to graph the y equal x line. That is the line where all ordered the x and y coordinates match. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. -1, -1, -2, -2, -3, -3, -4, -4, -4, -5. That's your y equal x line. And just graph that line. And what you should notice is that y equals x line is the line of symmetry between the inverses. Let's look at a few more graphs. Graph A is a linear function. The y-intercept is 3, the slope is negative 2/1. So I'm going to do several points and connect the dots. Looking at those ordered pairs and mentally reversing them, instead of 0, 3, which is a y-intercept, we would have 3, 0, so the y-intercept becomes an x-intercept on inverse. 1, 1 will be the same in reverse order. 2, negative 1 becomes negative 1, 2. And finally, 3, negative 3 becomes negative 3, 3. Connect the dots. And we graph the inverse. Here's the y equal x line. Just to verify that it's a line of symmetry. If you folded on that line, the function, the blue function, and the green function would overlay one another. Graph B is a horizontal line, y equal 2. The inverse of horizontal line will be a vertical one. X equals 2. And again, here's y equals x to show the line of symmetry. And graph C is a quadratic parent function. Giving us a parabola. If I look at those ordered pairs and I reverse them, 0, 0 would be the same, 1, 1 would be the same, 2, 4 would become 4, 2, negative 1, 1 becomes 1, negative 1, and negative 2, 4 becomes 4, negative 2. So we have a sideways parabola, which is not a function. We know that because it fails the vertical line test. So we could also look at the original parabola and realize that the inverse will not be a function because the original blue quadratic parabola fails the horizontal line test. So if an original function fails the horizontal line test, it's still a function, but its inverse will not be a function. And again, in conclusion, the big idea behind inverses is that x and y are interchanged, whether it's an ordered pair, values in the table, points on a graph, you interchange x and y, and inverses will always reflect over the y equal x line.